Hi, I'm Jeremy Simon. Welcome to another episode of 3D Universe Untethered. Today we're going to be talking about SmartSlice, which is a plugin for the Ultimaker Cura slicing software, which can automatically optimize your slicing parameters in order to achieve certain physical requirements for your printed parts. This can take a lot of the guesswork out of a very complex process that has many different variables involved. And instead of just trial and error, you can quickly identify the optimal parameters for getting your part printed the way you need. So let's start with some introductions. Doug, how about you first?
So I'm Doug Kenik. I'm the CEO of Teton Simulation, actually a fairly newly minted CEO. I originally came into Teton as a product manager because that's most of my background, and I have a lot of experience in continuous fiber composite materials, which are very analogous to the FFF process. So Teton is a company. We're based in Laramie, Wyoming. Our mission is to print better parts faster, and like the motto basically is print with purpose. We develop add-in software to traditional slicers, and what we do is allow users to optimize slice settings to minimize print time and material use while ensuring the part is functional. So basically, it won't break when it's put into service. Back in my time when I was at Autodesk working on their generative design solutions, kind of what I found is, generative design is really, really good to create geometries based on strength and stiffness, but what it doesn't do is take into account the manufacturing process. So a lot of the times, additive manufacturing is kind of bi-directional. Design influences manufacturing, and manufacturing influences design. And it's kind of like a handshake, right, that needs to be occurring on both sides. And most generative design technologies or topology optimization technologies, they don't take into that account. It's very unidirectional. Or design, you take some sort of an idea of a manufacturing process and you push it forward. And it works pretty well for like metals in 3D printing, castings and things like that, with materials and processes that behave what I'm going to call isotropic, which is a weird word, but we can dive into that later. But, when you have a process like FFF, where the process itself, how you print it, influences the strength so much, you kind of have to go backwards, which is a weird way to think about it. And that's what SmartSlice, that's why we created SmartSlice, is to help users gain confidence. I think Jason, sorry, you put it eloquently that way, that the part that you're going to print is the part that's going to work when you put it in service. Because what people have been doing is tribal knowledge, right? And that's, Jason, what you were talking about as well, is you just tweak it, you get a feel for what comes out the other end and what you need to do. Like, how long does that take? And so, that's really what we're about, is to allow users to gain confidence that their part is going to behave as expected. And that allows them to trust the printer, which is really the only way I believe that we're going to get into these production level types of workflows where you are creating functional parts, because otherwise it is just a toy, right? So, yeah, so that's kind of where, the background on Teton and where we're at.
Okay, thanks, Doug. And now I have the pleasure of introducing one of my favorite customers, Jason Enders from RE Suspension. Jason has been a pleasure to work with over the years, and he's been doing some really cool things with 3D printing, just leveraging it more and more in his business. So, Jason, why don't you tell us a bit about yourself and RE Suspension?
Sure. So I'm Jason Enders, and I own RE Suspension, which is located in Mooresville, North Carolina. And we sell and service shock absorbers for racing. From NASCAR and Indy cars all the way down to, your local dirt track stock cars. So we started this about 19 years ago, actually, 19 years ago yesterday, and been going hard at it ever since.
So tell us a little bit about how you got into sort of doing your own in-house 3D printing and how that's part of the business.
So 3D printing, it started, I had a customer come in one day and we were sitting on the front counter and talking, and I had just designed and prototyped a new widget for race cars, and I was showing it to him, and I was sitting there belly aching about how much it cost to just prototype this one part. And he he had just read an article or seen something about MakerBot had this new desktop printer, and it was like $2,500, $3,000, and I was like, dude, there's no way. It's like, I know what 3D printers are, and like they're expensive. And so he left, and I went back and looked it up, and that's like, well, I'll be dang. So I ordered it right there, and started playing around with it, and just really just playing. I wasn't prototyping anything, just trying to figure out how it works and what the 3D printers want to see and the slicing software wants to see and how to orient the parts. And I was playing around with it, and I had a I had a whole lot of trouble with that printer, which is how I got to you, Jeremy. I'd got fed up with it, and called one of your guys. I think he still works there. Called him, and you guys directed me towards an Ultimaker 2 or a 2 plus. No, it was a 2 at the time. And so once I started playing with it and building dumb stuff, business card holders and whatnot around the shop, it's like, all right, let's see how we can utilize this within the company. And we started making, it started off making fixtures around the shop, and trays to hold pistons and shims, to actually 3D printing functional brackets. And we use 3D printing a lot for when we test for data acquisition. So on a lot of these race cars, we'll have potentiometers and string pots and pitot tubes and all over the car. And the problem is making all these little brackets to attach this instrumentation to race cars is insanely time consuming, and it used to be expensive. So that's where we really started using 3D printing as a functional tool in the shop instead of a toy. Like we got it in here, and I was playing with it, and it's like we could use that. So we're making all kinds of brackets and stuff, and then it evolved into us, making tools and all kinds of stuff, up to we have end products now that we sell on the website, which is part of the case study that we did with SmartSlice on one of our parts. So it's become a very integral part of what we do.
So it sounds like as that 3D printing capability has grown and you've been able to see what you can do and the quality that you can get, you've been discovering more and more ways you can make use of it, including these end-use parts now?
Every day. Yep.
Okay. All right. So then I want to talk a little bit about what brings us into this discussion, which is sort of how you went about prototyping traditionally, just having this 3D printer. You want to come up with a new part. How do you figure out the right settings? How do you get it to where it's strong enough, works the way that you want, prior to having SmartSlice? And then we'll talk a little bit about what SmartSlice introduces and what your experience was bringing that into the picture.
Sure.
So let's talk first about how would you go through this with a part, especially where that has some element of where strength matters or it needs to hold up to certain sort of physical requirements. How would you have handled that previously?
Yep. So, well, just like I said, when we first got the printer, I just play default settings, hit print, and see what you have. And back at the time, I was using Simplify 3D and Cura both, and they both have phenomenal tutorials, help. It's like, between, the parts breaking, increasing wall thickness and infill and number of top layers and bottom layers, and you can play with the different infills and how strong they are depending on what you need, on top of orientation, right? So really before it was trial and error. It's like you print it and it breaks. It's like, okay, well, how did it break? And you got to look at it and, play. It's like, well, I printed it with the layers like this, and that shouldn't have done that. We should have gone the other way to make it stronger, and playing. And I just played with it until it didn't break. Yeah. And as time,
and like you said, there's a lot of variables in that process, right? You mentioned
so many variables.
So you might get it to where it doesn't break, but you don't necessarily know if you found the optimal combination of settings,
no clue.
Right?
No clue. It either broke or it didn't, right?
Yeah. Okay.
So as time goes on, you get faster with it, right? Because I mean, it's like this part doesn't require anything. So two walls and 10% infill, and it's fine. But the parts that require strength, just from messing with these things every day and printing stuff that break, it's like you kind of get a feel for what it needs, but you really have no way of quantifying it. And above and beyond that, no one wants to take the time to really go through and dissect, well, how did it break and why did it break? And you're looking at it, it's like you throw it away and you increase wall you just mess with it until it's right. So, and again, the longer you mess with the software, you get a good feel for it, but I'm sure there's so much stuff that what do you want to call it, overprinted?
Right.
Just to, and it took 7 hours longer in the printer than it really needed to, but it's like, well, it didn't break, so you move on.
Exactly.
And
Exactly.
it goes back to SmartSlice when you introduced me to this, and I started thinking, it's like, oh man, how many hours in the printer could I have saved, let alone the strength. It's like, because we all can make strong parts. I print it solid. It's like, but
Right.
so
Doesn't necessarily mean that's optimal.
right, exactly. But so this came along, and I mean, before I even got the software, it's like, I can see where this is going to be a home run.
Yeah. Well, that's what I thought too. I knowing what you do, it just immediately seemed like something that you should be aware of. So I thought it would be great to get you guys together. I'm so glad we were able to do this and connect you guys. Jason, tell me a little bit about this process as we went through this exploration together. Let's start with what you decided to use for this experiment. What part or parts did you guys zero in on to test out with SmartSlice?
Oh, well, it was very unfortunate timing. So you guys, I think it was you, Jeremy, called, or no, it was somebody from SmartSlice called, and it's like, hey, we're going to do this, and we're looking for some parts. And I remember I turned around, and I just had I had just run an entire batch of those piston trays that we were doing actually for another customer, and I had issues with the post breaking off. So if your viewers want to go back and pull up that case study from SmartSlice, basically it was just a really big round post with a really small post on top of it, which as a designer, when I designed it and I'm looking at it, it's like, oh, like that's going to be tough, right? So they'd called, and it's like, well, I just happen to have this part right here, and we took off and ran with the piston tray because we're selling these things like 20 at a time, and the customer called, it's like, well, we broke 4 of them, I need 6 more. So I was playing around with the wall thickness right there and just trying to modify that one section, and not, again, right back to where this whole thing started. It's like I didn't know if it was over design, under design, and so they ran the case study, and what impressed me actually more than getting these things to stop breaking was they took, like, if I remember, it was like 3.5 hours of print time out of it, and that was big for something that was taking like 18 hours to print. I don't remember the actual numbers, but it was a considerable time saving. So I can, when that job's running and I got to do 20 of them, I mean the printer's tied up for 2 weeks. I can't do anything else. So if we can cut 3 hours apart out of there, it's like I can get a couple days back, of getting new parts onto the printer. So there was a couple other things there. We had a dash bracket that we were making for a flat track motorcycle, and it was a rear end bracket that just had way too much load on it for anything plastic. So we did all 3, and out of the dash bracket there wasn't much time saved. But the issue, it was the same deal with the dash bracket. It was kind of a flat bar with just a post on top, and if the thing took any kind of a side load, it wouldn't necessarily break off, but it would crack and bend it. So and it's ran it through the software and fixed.
So,
You know?
Okay.
that's interesting.
So-
I want to, sorry, Jeremy, I wanted to
No, go
kind of
ahead.
go back to the piston tray. So you said, like customers calling and they're saying, I need 4 more. Like that's a good problem for you to have in one viewpoint, right? Because like
On
cool,
one
I gotta sell
viewpoint,
more.
but on the other hand, there it's like, dude, if you can't fix this, I'm going to find something else to do. So,
Right.
yeah.
Yeah.
So,
So,
and they understood that it was 3D printed, and it's like if you drop these things off of a top of an 8-foot cabinet and it hits the floor on the post, it's like, dude, it's going to break. I'm sorry, but they were breaking. I agree with them. It's like it's breaking too thin, and
Sure.
there was no way that I could put, a bigger radius where that post comes up, because we had shims and pistons that sit all the way down on it. So my radius had to be real minimal at that edge. So
and what I found so interesting about that specific case study is if you wanted to increase the strength of that using like traditional knowledge, you either had to change the material and guess, or you had to literally print the entire thing solid, or like different raster orientation, or change orientation, whatever you want to call it, right? Which is like,
Right.
that's just a huge waste of time and material.
Huge.
And it was like SmartSlice was actually able to go in and just, I don't know if people know this, but in Cura, there's something called like an idea of a modifier mesh. Where like you have a big geometry and you can bring in another piece of geometry and you can ask Cura to locally modify slice settings based on this other geometry. And SmartSlice takes advantage of that and will put these little modifier meshes in there and locally tweak slice settings to make parts stiffer and stronger just in this certain volume, which is what we did for that, or which it did automatically for that piston tray. Is it just like, look, every time that you have the diameter change, just insert a new mesh there and increase the thickness. And now all of a sudden you have a part that survives, but you're not increasing the print time drastically. And actually turns out we reduced the print time. So
big time.
So that's super interesting.
Because well, before, when I would increase my infill and Walsa, it did it throughout the whole part. So, down at the base of this part, I had it at 35 or 40% infill. Well, it did the whole thing at that. Well, the base doesn't.
Sure.
The base can be 10,
Yeah.
because there's nothing. There's no stress on that part. So, by decreasing what the base was and then just putting, like you said, modifying it just where it needs to be modified, it killed a bunch of time out of the part.
Yeah. Yeah, I've done videos before on the modifier meshes that Doug talked about with Cura, and there's some great capabilities. But that's what I've seen always is the real key value here with SmartSlice is that it takes away the guesswork of how to use those very powerful tools.
Yep.
Okay, I have a modifier mesh. I can customize any region of my print with all these different settings, but what needs to be modified and how?
Right.
So, SmartSlice takes care of that hard part. And it occurs to me, I want to get your input on this, Doug. When I think about how you can deal with some of these challenges of a part maybe that isn't holding up to certain stresses, obviously there's the design side of things. You talked about some of that with generative design and some of those other approaches. But however you do it, somehow going back to the original design and modifying that design in order to strengthen or thicken or somehow modify the part is one option. It seems to me that SmartSlice in some way sort of relieves a little bit of that burden of making sure that the design is perfect. I don't know if you would agree with that you can take a part that might not have ideal design considerations, especially when you think about how it's going to be printed, and you can compensate for that by adjusting the way it's being sliced. Would you agree with that?
Yeah, and I think this goes back to my comment where it's kind of bidirectional, but I think we kind of got to get back to the root of the problem, which is like, there's this term that's being thrown around in the industry, and I cringe when I hear it, and I'm sorry for those people that use it and like it, but it's called design for additive manufacturing. Like DFAM is the short of it. It's thrown around in the software world a lot, and like, what does that mean, right? Like, this comes down to education at the end of the day, really is what, because like injection molding had this same problem, and we didn't call it like DFIM, right?
Right.
It's like go learn how to design for the process at the end of the day.
Yeah.
The problem is there's way too many variables here, like especially with FFF. There are way too many variables on the actual like manufacturing side to get educated on all of it. Like it comes down to tribal knowledge, and that's this is extremely difficult to grasp. So you need tools to help you understand how to do it, right? So I guess that's my long-winded answer to that. Holy Grail, you get a design software which has the slicing software integrated, and generative design can go virtually print the part, understand how it influences the design, and it can tell you and navigate you through the waters. We're not there yet. I mean, I want to see that happen. I think it would be amazing if that happened at someday, where all of it lives in CAD and you're just like, real time iterating on this kind of stuff. But for now, like, yeah, we don't know how to design for FFF. When you try, you just print it solid.
Right.
Because that's how we've been trained, right?
Yep.
Like, it's a solid part. So yeah, no, and that's why we created SmartSlice, is to help you design how you want to design, how you know how to design. Take it into the slicer and let us help you get what you need on the other end.
So there were a couple of other parts that you did as part of these tests, Jason. It looked like you're working on some brackets as well. Do you want to talk to us about those other experiments?
Well, that's what I was talking about earlier, the dash bracket that had the flat bar with the post that was
got it.
that was still getting pissed. And then we threw in there, he wanted something tough. It's like, give me something tough. And I had to think about it for a little bit. And it's like, okay, well, when we're setting up race cars and running through ideas, and I'm trying to think prototyping in the back of my head, it's like if we had the ability to make this, it was a top link bracket, the third link bracket that goes on the top of a rear end. If it was possible that we could 3D print these, throw it in the printer at 4:00 at night, come in the next morning, they're done, let's bolt them up and run the suspension through travel, not on the track, just in the race car, but statically. I think there was if I remember right, 450 pounds of load in one direction, and it was too much, too much load for the plastic. But nonetheless, we went through the exercise to see, what the software would kick back, and it kicked back what we all thought at the beginning. It's like, yeah, no, that ain't gonna work. So it was cool to see that, and just if nothing else, for validation that we should not waste our time printing one of these and then bolting it to a race car and hooking the top link in and setting the car down and it folds up. It's like, okay, well, that was an exercise we didn't need to do.
Interesting. So that's a little bit different. That's more like kind of proving out a theory, hey, what would happen if we printed it like this before you ever have to send it to the printer? You can figure out what that would result in. That's
just ask the software. It's like, hey, I want to do this. I think I'm outside the scope of what FFF, printing can do, and you run it through the system and it'll tell you. The hardest thing that I've found out using the software right now is knowing your load constraints, because so much of the stuff that we do, it's hard to quantify that. We don't have the measuring tools, or we just simply don't know. So you sort of have to guess. You gotta tell the software how much load to apply. It's like, how hard are you going to hit this, or how heavy is this part that you're going to hang off of it? So that's the hardest thing that we've found out with some of the parts that we're using, just, quantifying a load.
Yeah. So, and this is universal, right? Because this requires some sort of engineering training, know, and we've taken a stance where it's how do we make this as simple as possible? Right? There's a whole bunch of FEA packages out on the market right now.
Right.
Embedded in CAD and all this other kind of stuff. And you get in them and you're like, where do I start? What videos do I have to go watch to get through this? And so we've kind of taken the approach of let's make it as simple as possible. Holy Grail for us, which is what we work towards, is you show us enough things, we'll be able to tell you. This is what this should look like, and this is probably what you're doing, and all you have to do is say, yeah, that looks really good, right? Or I don't know, let's just move forward with that. So that's kind of where we want to go. But yeah, right now there's some sort of still education in the process where you just have to say, I think this is it. So then it's I think this is where the load is and how hard I'm pushing on it, and then you say, I'm 50% certain. So you take the uncertainty level basically, which is, a factor of safety, and say 50% certain, 2. Then the software is like, okay, well, let's just get you in the ballpark, which is what we're really trying to do, is say,
sure,
don't go this way, go that way, right?
Right.
But I agree with you. It's way easier to virtually simulate at the end of the day, because that takes you 20 minutes rather than printing it and putting it on, right? Because then you've wasted a day. So,
right. So let's talk about that a bit. I mean, at the end of the day, it's really about what kind of value you get from using something. So let me ask you, Jason, now that you've had a chance to work with SmartSlice on a few different parts, what made you unique in my mind, the reason I reached out to you, is because you're developing so many different parts all the time. It's not like you're just printing the same thing over and over again. You're constantly coming up with new things, and each one has a different set of requirements. So what do you see going forward? Do you think that SmartSlice is going to be a part of your default sort of prototyping process going forward now that you have access to this tool?
Oh, 100%. Because again, we're a small company. We've got 9 guys here, and I'm the one and only engineer, and so I can only do so much. And if the time spent, the time that I get back from using the software and not reprinting something or opening up SolidWorks and changing the geometry of the print or the CAD model, or all that time saved is something that I can move on to the next thing while it's printing, and I don't have to worry about it. And there's a handful of things that we don't run through SmartSlice because it doesn't matter. It's a widget, but the functional parts that that need to be good right out of the bat, it's a default. Run it through there, and when we started talking, I don't know how many times now I've used SmartSlice to know what materials are actually available, because I can't. Every time I talk to you, Jeremy, and Doug, and all you guys, it's like I learn about new materials that are out there, because I simply don't have the time to sit down and read through the white papers and go to everybody's website and stay on top of it. So I've used a half a dozen times now. I've opened up SmartSlice and just scrolled through the stuff that's available. It's like, what is that?
Yeah.
Yeah. So,
and I think that's really good, and that's really good for the audience too. Like, listening is another customer that we have said it really well, and I totally believe it. Is I don't think SmartSlice is meant to be like a flathead screwdriver, right? It's kind of that tool that sits in your toolbox when you need it. You're really happy you have it. And, and that's okay. Like, we as a company and we as users should be okay with that, right? Like, it's all about saving you money. And as long as your ROI is attached to it and it's providing value, then it should be in your toolbox, right?
Yep.
So.
Yep.
Hey, those piston trays that you've made, now that you have printed some of them using these optimized settings from SmartSlice, have any of those worked their way back to your customers? Have you gotten any feedback on those new ones?
None have broke so far. So
good sign.
Again, it could be luck, or it's like, nope, we hit the optimal design for 99% of the cases out there. But yeah, none have that I'm aware of have broken since we've done it. We've done probably 2 more batches of 20 of those, so there's probably another 40 out there that
and no reports of breakage.
Nope.
That's a good sign.
Knock on wood.
Exactly. Thanks, Jeremy. You just wrecked it now.
Yeah.
Hopefully none of those customers listen to this podcast and they're like,
Yeah, it's like, hey, let's see if we can break this.
Yeah.
Right. Yeah. Well, but again, we've run the well, here, hang on, let me think a second. I don't think anything that I have run through SmartSlice has failed. So yeah, I'm pretty sure all the parts that we've run through there, none of them have failed. So again, knock on wood.
Yeah, I know.
So,
just put more pressure on.
Now you have a whole bunch.
Right.
I'm gonna have to go talk to the team and be like, gosh, guys.
Right. But again, so much of the stuff that we design, it goes back to what you were saying, Doug, about design intent. When you're laying this part out, it's like we try to, like, we know we're making this out of plastic, so over engineer it a little bit and make it thicker than it than it needs to be here and there. So design intent when you're drawing these parts up goes into it, and for the most part everything that we draw, we over design a little bit and then let SmartSlice make up the difference with in doing it in FFF and using PLA or ABS or carbon, whatever the material is, and let it make up for the deficiencies of not using a metal. So it works fine.
Yeah, like you don't have an isotropic material in that design, right? And
right.
And by like for the listeners, isotropic, it's basically like if you pull on it, it responds the same. Like if you pull on it in any direction, right? That's kind of what it means. And the opposite of that is anisotropic, which basically means if you pull on it in one direction and another direction, it responds completely different. Which is why build orientation matters so much in strength and stiffness for FFF parts. But yeah, I agree, and I think that's the perfect way to go about it is. Yeah, design it like you were designing it with metal, over-design it a little bit, and then allow SmartSlice to guide you in the direction that you need to go, right?
Yep.
And it might tell you, hey, this isn't possible. And it happens to us all the time. We'll put something in there, and it comes back and says, this isn't going to work. It's like change the material or change the geometry.
Right.
And it'll tell you, like, on the geometry, this is where it's not going to work. So go modify that one, right? If you don't want to change the material. So.
Well, and the way that you guys lay out the software, I mean, it shouts at you like with big red signs. It's like, hey, right here. So it's and typically when I've run across situations like that, I'll go back to design. And that's the first place I'll go. Instead of asking all these different materials, it's like, well, if that's a weakness, is there something that I can do design-wise to change that to alleviate that stress area? And then if not, then it's like, well, you got what you got. Here, go find me some materials or settings that'll work. And it's one of the things you hit click, you go do something else in the shop, and 15, 20 minutes later, it's run its deal. You pick one and go.
Yeah.
So.
And I think that's really good feedback too, because there is I think we're just keep going back to this bi-directional thing where the easiest thing to do is just to go back to your design software and say, let me just tweak that a little. Like, what is that?
Right.
A 5-minute change for you probably,
right.
And then you just get to go ask SmartSlice again. I mean, like holy grail for you, Jason. Like, what would this look like? Because right now you're probably starting in CAD and an idea, and you design something, you take it to the slicer, which I would imagine is what you're doing. Then maybe you're working with SmartSlice and asking it what to do, and then you go backwards, or do you go print it? Like what would be ideal state for you? Let's say 2 years from now.
Typically, I'm not quite sure how to answer, but typically, like I said, the first thing that I'll look at is when it comes back is just look at it right here in Cura, and it's like where it says it's failing. Is there something that I can do design wise to change this? Whether it's add fillets or beef it up, more material, change angles, whatever it is, and or change orientation.
Yep.
And if I don't think anything can be done there, then like I said, I let SmartSlice, it's like, hey, find me a material that's got the right safety factor that I'm looking for, and let's try it. And then we'll print it, and assuming it's a big print, come back the next day and see if it worked.
Yeah. So I'm gonna hijack that a little bit. So if this all lived in your CAD design system, would that make it easier for you?
Oh, 100%.
What are you using right now?
SolidWorks.
Okay. Like 90% of the population probably.
Yeah. This whole Yep.
No, yeah.
This whole town operates off of SolidWorks. So, yeah.
Yeah, I guess that's kind of where I'm going, right? And that's where, we as Teton as a company see this, 3-5 years from now is this all should just live in your design software, right? Or at the end of the day, why are we shifting through multiple pieces of software to accomplish one goal, right?
And we've got FEA and SolidWorks. We've got the whatever version you're supposed to have to get all that. but it's not applicable to 3D printing.
No.
So, it's you work with what you got. So yeah, in a perfect world, it'd be nice to draw it right in there and just hit a button. It's like, hey, I want to print this thing. Are we good? And it looks at it and it's like, not really. Let's tweak this or change that, and then just send it to the printer.
Absolutely. Yeah, and then everything lives in
Yeah,
one
I agree.
system,
I mean,
too.
because right now, I don't use SolidWorks, but I use Fusion 360, and they have some slicing capabilities built in there, but it's like so basic.
Yeah.
It's almost like it was an afterthought to them.
I think SolidWorks has that too. They've got 3D printing capabilities, but to be honest with you, I've never even tried it. So
it just can't compare with
Right.
Cura.
Mm-mm.
So until they get that to the right level, it's going to be hard to put it all in one place.
Yeah, and I think we have to be honest with ourselves too. I mean, the printer manufacturers have invested a lot of money into these slicing programs, and the reason is they need to make sure that their customers are as successful as they possibly can be, which inevitably means there's a whole bunch of IP that's tied up in these slicing programs, right? So creating a slicer or a printer manufacturer or printer agnostic slicing tool in a CAD software, it doesn't right now work. And that's because you're not acquiring the IP that is needed to make sure that the customers are as successful as possible, right? So this, again, kind of comes back to like trust and confidence, where there's a reason all these slicer programs are tied to printers.
Yes.
It's because like they work. And they work well, and like
on default settings.
Exactly.
Right out of the box. It's like, here, don't change anything. Just hit print. You'll be pretty good.
Exactly. Like, will that change in the future? I mean, like the cam industry, it changed in the cam industry, right? Where you saw a whole bunch of consolidation, and then like there were a few that emerged out of it. That might happen. We don't know, but all I know is like I want it to be in CAD as a user. Like I'm not even like I use the software, right? Like we all use the software here at Teton, but as a user, I want it to live in CAD. I want it to be like CAM. I want it to be as easy as CAM, right? It's just not there right now. So,
yeah. Well, I wanted to ask about that, so let's continue on that for a moment, Doug. I was going to ask you about sort of the plans for the future for SmartSlice. I don't know if there's anything else you can share. That's one ambitious goal. Anything else that you have in mind for future capabilities or anything for this roadmap?
Yeah, I mean, like at the end of the day, from a business standpoint, right, it's all about increasing our total addressable market. And so there's two ways you can kind of think of that. One is what problems do you need to solve that are pervasive in the industry? And the other is like, have you addressed all the users out there in FFF or in other processes? And it's no to both of those. So there's a huge area that we can go attack. But at the end of the day, it's how do we integrate with more slicers, right? We want to make sure that we can provide this technology to everyone who has a 3D printing process, because the problem is pervasive across different printers and different processes. So we want to do that. The other is something that we're pretty excited about is the National Science Foundation has given us a grant to look into predicting warpage and delamination off a build plate. So you could actually create SmartSlice to go back to a user and say, don't print it like this because it's going to peel off the build plate.
It's going to pop.
Yeah, or you're going to have a delam in the middle of this, right? Which
how cool.
Right? So this is a
nice.
huge problem. It's a huge problem. And it spans way past functional parts. Like a tchotchke has this problem. Like if you could just click a button and say, like thumbs up, thumbs down.
Right.
Can I print it? That's
well,
cool.
It would seem to me that if you're going to move in that direction, maybe an even more achievable goal would be to incorporate print orientation in the analysis to be able to actually analyze different orientations and figure out the optimal.
Yeah, so that's on the roadmap too. That's something that we hear a lot,
Excellent.
right? And that's something that actually popped out of this case study that we did with Jason on that.
Yeah, that was the first question I asked when they came back and showed me the results. I'm like, well, will it tell you the best way to orient? And they were like, no, not yet.
Right, not now. Yeah. But yeah,
so that's really tricky too, because what is best? Well, it depends on what you're looking for, right? What's important in the outcome.
And this is why we give users multiple options, right? So when we come back after an optimization, we don't say, do it this way. I think that is the wrong way to approach an optimization. What we do is come back and say, here are like 5 different things that you could do. And we can't capture all your requirements, right? Like we just can't. There's
No,
there's
because
stuff
you don't
in
know
there.
the end use. There's
Exactly.
too many variables for you to take. Yeah.
Yeah.
Yes. So we say
No,
you're
and
an engineer, figure out like you decide which ones you want to take forward, and that's what we're trying to do with build orientation optimization. Because like as Jason said, that is the first question we get from every single customer. Is like, can you tell me the best orientation? It's like for strength, we totally could, and stiffness, we totally could come back and be like, this is the best orientation. But what we're not getting there is like, do you care about that? Like, what is the balance of the support material that you're going to have to use?
Yeah. Where do you want which surfaces need to look the best?
Does it
there's a
fit
lot of
into your
different
build
variables.
envelope when you do it that way? Like, there's all these different things that kind of come in there, and that's kind of, the team's getting their head wrapped around it right now. But we definitely want to do that. We also want to include like a full-on material suggestion, because right now we say, hey, go try different materials. We just allow you to select materials and you can go try them. We also want to come back and say, hey, these 3 materials, they work, and like
That's a great idea.
and then you can say buy now, right? Because then we can integrate with like whoever and just like you click on it, buy, and then the material comes and you're like, okay, I'm ready to go. So yeah, I mean, there's a whole bunch of stuff we can do here, right? But it really comes down to pervasiveness in the market and how severe the problem is to solve.
So Jason, I've said it before. I thought you would be a really good candidate to explore this product, and again, part of the reason has to do with the diversity of things you're doing with 3D printing. But there's another interesting aspect here, and that you are a person who comes from a manufacturing background, who was doing that before knowing anything about 3D printing,
Right.
then getting into 3D printing and doing it kind of the hard way of just trial and error. And then going to this sort of next level of 3D printing with SmartSlice. So in a sense, I see you as going through all of these phases. Tell me a little bit about what your experience has been through that before 3D printing, and then with 3D printing, and then after, adding SmartSlice into the mix.
So my experience with just how we designed parts back in the day, or?
Yeah, I mean, I guess what I'm getting at is I'm assuming that you've seen benefits in what you're able to do and how quickly and how cost effectively once you add it in 3D printing.
Yes.
And then are you seeing that benefit improve further with the addition of SmartSlice? Are you seeing this as a way of leveraging those benefits that you're getting from 3D printing even further at a financial level, I guess is what I'm looking for.
Well, so as all these printers get better and the software is advancing, the parts that we were printing 5 or 6 years ago, I mean, they looked okay, and they were functional. But now, with the finishing techniques and again how the software is keeping up with your feed and your flow rates, and you can produce really good end use parts that take very minimal effort after cleaning up and deburring and whatnot. So what I was looking at using 3D printing for 5 years ago, now we're looking at how can we take this 3D printer where the cost to run it is actually really low. I mean, the printers don't cost much, and in all reality, the filament costs hardly anything. When you look at the cost of any part that you make, it's, I got like, $3 worth of material in this. It's nothing. So we're looking at how we can use 3D printing for end use products right here. The only downside I can say about 3D printing is volume. If there's something that you want high volume of, you either need to buy a lot of printers or do something else. Go back to machine shops that can crank these out. But that's the only drawback. So yeah, 3D printing is still mainly prototyping. But
it sounds like
capabilities, it's like the end use products. It's designed correctly, and if it's strong enough, the end use product is right there. So
I hear you. Yeah, and that very much reflects my experience too. So the machines and the materials have gotten better to the point that you can get much higher quality parts out of these machines.
Yeah.
And it sounds like what SmartSlice is doing is primarily a time-saving tool, because as you mentioned, the machines aren't all that expensive, the materials aren't all that expensive. It's the people's time that's going to cost you money over the long run, right?
Correct.
So if SmartSlice can cut out some of the time of having to do all that trial and error, that's where your savings are going to come from.
Yep. And again, on the let's call them production runs, of parts. Again, going back to my piston trays, what would take, 9 days to print, I can do in 6.5. And it's like, well, there's 2.5 days of open printer that I've got that I can move on to the next project. And that's huge,
Absolutely.
That's huge.
Especially if that's a part you got to print more than once.
Right.
Then it starts to add up.
Yeah,
Yep.
I mean, like half of it's just increasing throughput, right? I mean, as an end
Right.
user, Jason, right? Like I would imagine like tying up a machine is just taking you away from something else. And like,
Yep.
Well, that's a true statement. But I mean, I think like a user's likelihood of buying another machine increases if they can show that they can increase the throughput of the machine, right?
Correct.
Does that make sense, right?
100%.
So, I don't think we're going to cross the volume barrier anytime soon. Like,
I don't either, because it's its own, it's the nature of the beast. I mean, it's, we're printing one layer at a time. We can only go so fast.
Yeah. Yeah. But definitely, like, if you can eke out efficiency gains in any kind of aspect of it, that's a big value proposition for anyone in 3D printing. So I'm happy to hear
Absolutely.
you.
Yeah, I mean, it's long been talked about the fact that the key value of 3D printing is customization, that customization is free. You do whatever you need. But the flip side of that is customization adds that complexity in, because you're doing something new and you got to figure out each time, how do I orient it? How do I print it? And so this to me really helps with that side of the, taking advantage of that flexibility of 3D printing in a way that doesn't necessarily complicate things and add a lot of time to your workflow.
Right.
So that's what excites me.
Yep. Just right now, we're printing. It's a bracket to hold data acquisition sensor on a little bar, and there was no reason for me at all to run this through SmartSlice, because it's not,
Okay.
again, it's holding a little 1 ounce piece of electronics. But I ran it through SmartSlice, and I think because I'm printing 20 of these things at a time, and it knocked like an hour and a half out of the print. so it's like, well, cool,
Yeah.
And just using it for the time savings is worth the price of SmartSlice to me. Just the time savings, let alone the failed prints and making sure that the part is strong enough for the application and whatnot. Just the time savings alone is, it's already paid for itself, and I haven't had the software for 3 months, 2 months.
There you go.
So yeah.
Oh, that's great.
What I like to hear the most, and this is really why I wanted to get on the call with you, Jason, is just like the confidence that it allows you to have moving forward.
For sure.
Right?
Yep.
And I'll be interested to hear your opinion on this, Jason, as well. And maybe this can be the ending note. But I firmly believe, there's a whole bunch of market consolidation happening in the 3D printer space right now. I firmly believe the ones that are going to be successful and emerge victorious or winners are going to be the ones that create ecosystems where their customers are so successful that there's
no reason to go anywhere else.
Exactly. And the barrier to exit's pretty high too, right? Yep. So I'm lucky, and Teton's lucky in that, we work with a lot of different printer manufacturers, and we get to see the landscape and how it consolidates. I don't want to give plugs to Ultimaker here, but we absolutely love working with Ultimaker. They are an awesome partner. They were the first to adopt us as a software provider, and they definitely are working on some of that ecosystem play. But Jason, I'd like to get your opinion on that too. Kind of what you're seeing out in the industry in 3D printing, and even on the material side. So, how you view the landscape. Who do you like? How do you chose Ultimaker for a reason? I think you chose it because Jeremy kind of was like, hey, maybe.
Well, because he steered me there. And I know we joked about it that one time. It's like, well, why'd you choose Ultimaker? It's like, because that's what Jeremy told me to buy.
For me, it was about the reliability. I mean, there's a lot of good machines out there, but I like Ultimaker when it comes to wanting a machine that will do what it's supposed to do so you can focus on your business. And that
was
like
my
what
big
Jason
thing.
was looking
It's like,
for.
well, when I called, it's like, I want to print. I don't want to work on it. If and there's a lot of guys out there, and God bless them, that want to buy the kits and put all the stepper motors together and wire it and Arduino boards, and it's, dude, you can have that. I've got I need to have a printer that I can send something to it and hit go and it goes.
Yeah.
And
You got a company to run.
I absolutely. And I've had to work on these printers. I had a stepper motor go bad and some hot ends that finally quit working on us. But
Mhm.
I can't see me ever wanting to buy anything else, because even with this new one, I got the S5 sitting back here, and we're getting ready to buy another one because I don't. There's no issue. They have given me no reason to look any further.
Yeah.
And again, not plug in Ultimaker. It's just it
No.
happens to be what I landed on. But
Yeah, it's working for you. That's great.
going back to what you said earlier, Doug, that's these printers, as everybody's consolidating, those are the guys that are going to win. It's like all you got to do is get them in the door, and then there's no reason to look anywhere else. That the printer has never not been able to do anything I've asked it to do.
Yeah, there's like a barrier of exit there, right? And like
Right.
like it's just too high for you right now, right? Like you're just like,
Yeah.
there's no reason, right?
There's no reason.
That's a fine barrier.
Well, this has been a great discussion. I certainly hope our viewers have found this useful. For more information, visit us at shop3duniverse.com. That's where you can find the SmartSlice software, and you can always visit 3duniverseutethered.com for the full list of upcoming episodes and recordings of previous ones. Hope to see you next time. Bye-bye.